you're having trouble with probability, this video is for you. What is probability? In technical terms, probability is a branch of mathematics that measures the likelihood of an event. But in all honesty, probability is all around us. From when you check the weather daily, to playing rock, paper, scissors, to generating any prompt on any AI, all these events are deeply driven by probability. At its core, probability is really simple. In math, we measure it by the number of desired outcomes divided by the number of possible outcomes. We call our desired outcome the event, and we call the possible outcomes our sample space. Let's look at an example. Let's say we roll this fair six-sided die. What is the probability we get a 1? The total number of outcomes, we have 6 possibilities. We can land on either 1, 2, 3, 4, 5, or 6. And our desired outcome is just 1. So our probability of getting a 1 on a die roll is just 1/6. Now what if I ask the probability that the die doesn't land on 1? Again, the size of our sample space, or our total number of possibilities, is 6. And we have 5 outcomes that aren't 1. 2, 3, 4, 5, or 6. So our probability of not landing on a 1 is 5/6. So our probability that we get a 1 on our die roll is 1/6. And our probability for the opposite, that we don't get 1, is 5/6. When we add these two together, we get 1. And this is no coincidence. What we just saw is called the normalization axiom of probability. Or in simplest terms, if you cover all events in your sample space, their probabilities add up to 1. This makes sense because if you cover all possibilities, something must happen with 100% certainty. This also tells us that probability is always between 0 and 1, with 0 being practically impossible, like waking up to find $1 billion left at your doorstep, to 1 being a shoo-in guarantee. Everything else lives in between. The opposite that we computed in our earlier example has a name. The opposite of an event is called its complement. If event E happens, its complement does not happen. A complement's probability is always 1 minus the probability of an event. Equivalently, we get that the probability of an event plus the probability of an event's complement equals 1, which again makes sense. Think about it. For any given event, it must occur or not occur with 100% certainty. When dealing with probability, there are probably a couple of other terms we hear. One of the most popular ones being independent events. 2 events are independent if one does not affect the other. So let's go back to our example. Let's say we roll the die twice. The first roll has no effect on the second roll. So our probability on our first roll is 1/6, and so is our second roll. If 2 events aren't independent, then they are considered dependent. Let's think of an example. Let's say I randomly draw a marble from a bag that has 5 blue marbles and 5 red marbles. I want to know the probability of getting a blue marble on my first draw. Well, if we remember how probability works, the size of our sample space is 10, and the size of our event is 5, because there are 10 marbles in the bag and 5 total blue marbles. Now let's say I pick out a blue marble on my first draw, and I don't put it back. What's the probability of me picking out a blue marble on my second draw? Well, now the size of our sample space is 9 because I didn't replace that marble, and the size of our event is 4, so our probability is 4/9. So what we see here is our first draw affected the outcome of our second draw, and these 2 events are not independent, aka dependent. You may hear 2 events being called mutually exclusive or disjoint. This is just a fancy way of saying these events can't happen at the same time. For example, you being born in Brazil and you being born in Germany. Those 2 events are mutually exclusive because it's impossible for those 2 events to happen simultaneously. In general, an event and its complement are mutually exclusive. Let's think back to our die example. We identified our event as getting a 1 and its complement as not getting a 1. These 2 events cannot happen at the same time. I can't get a 1 and not get a 1. It's either one or the other. So to recap, probability is just desired outcomes over total outcomes. And in math, we call that the event and sample space. Probabilities add up to 1. A complement is just the opposite of an event happening. We have independent and dependent events. We also have mutually exclusive events. This was just a high-level intro to probability. In future videos, I'll dive deeper into things like random variables, distributions, expected value. So if you're really trying to get probability, I'd say stick around and practice these skills. Thank you.